All right, today we're doing something a little different. We're going under the hood, deep into the code and the core logic of one specific, really powerful tool. We're going to take apart a quantitative crypto trading tool, pretty much line by line, to see not just what it does, but how it actually thinks. So if you love seeing how the sausage is made, from the very first problem to the last line of Python, you're in the right place.
So this is Venus Radar. It's a free, community-driven project that's basically an early warning system for crypto traders. Its whole reason for being is to act as a risk guardian, a system that's just constantly watching the market for any sign of a crash. This is so traders, especially those using automated bots, can get their money to safety. But how does it actually do that? Well, to get its logic, we have to start with the specific problem it was built to solve.
You know, every great piece of software starts by scratching a real itch. And this quote from the creator of Venus Radar, it gets right to the heart of it. This wasn't some abstract project. It was born from a real need felt by traders using what are called neutral grid bots. Now, that strategy is great in a stable market, but it gets absolutely crushed by a sudden one-way move. The entire complex algorithm we're about to walk through is built to answer this one simple but super critical question.
Okay, so here's our game plan for breaking this all down. First, we'll pin down the exact problem for grid traders. Then, we'll see how the system cleverly scans the market. We're going to spend most of our time inside the scoring engine itself, looking at its 10 core metrics and what I'd call its mathematical heart. And finally, we'll connect all that code to a simple Telegram alert and wrap up with the whole philosophy behind this open source project.
So let's start with the fundamental challenge. If you're running a neutral grid bot, you actually love volatility. Your bot makes money by buying low and selling high as the price just kind of bounces around inside a range you set. But not all volatility is created equal. There's a huge difference between the good, profitable kind and the kind that can completely wipe you out.
And this slide just lays it out perfectly. On the left, that's the dream scenario, right? The price is just bouncing around inside a nice little channel. The bot is happily buying on the dips, selling on the rips, and making a profit on every little bounce. But then you look at the right side. That's the nightmare. The range breaks. The price just picks a direction and goes for it, never looking back. Your bot is either left holding a bag of buys as the price tanks, or it's sold everything on the way up, leaving you with massive unrealized losses. That is the exact scenario Venus Radar is built to warn you about.
So this brings us to the million-dollar question from an engineering standpoint. How do you design an algorithm that's smart enough to tell the difference? How do you program a system to say, okay, this little 5% move, that's just market noise, it's profitable, we're good. But then scream, whoa, this 15% move is a breakout. This is a real change. Shut it all down. Answering this question is pretty much the entire point of the Venus Radar v3 engine.
Okay, so before the algorithm can analyze risk, it first has to decide what to even look at. I mean, trying to scan the entire crypto market with thousands of trading pairs is just slow and inefficient. So the first bit of really clever design is how it filters everything down to focus only on what actually matters right now.
It uses a really smart four-step process. First, it grabs a snapshot of everything. Second, and this is super important for avoiding false alarms, it filters by liquidity. Any coin with less than $5 million in daily volume gets thrown out. Why? Because those low liquidity coins can have these insane, meaningless price spikes that would totally fool the algorithm. By focusing on liquid coins, the system makes sure it's looking at real market moves. Third, it sorts everything left by volatility. And finally, it just takes the top 40 movers. This whole process is about focusing its brain power on the coins that are the main characters of the market on any given day.
Now, once we have our 40 coins, we need their chart data. And this brings up a classic problem for any analyst, the constant battle between noise and lag. If you use a high time frame, like a 1-hour chart, your indicators are going to be smooth, they're reliable, but they're slow. By the time they signal a crash, it might have already happened. On the other hand, if you use a really low time frame, like 15-minute data, you're super responsive, but your data is just full of random noise that can make your algorithm panic over nothing.
The way Venus Radar solves this is with a pretty elegant concept called high-res stability. The whole idea is to get the best of both worlds. Here's the trick. The system pulls in that fast 15-minute data, but it mathematically stretches its indicators. So, for example, instead of calculating a 20-period moving average on a 1-hour chart, it calculates an 80-period moving average on the 15-minute chart. What you get is an indicator that has the smoothness of a 1-hour view, but it updates with the speed of a 15-minute chart. Let's see how that actually looks in the code. And boom, Here it is, right in the Python code. You can see it clear as day. The time frame variable is set to 15M. So, yep, we're pulling that high-frequency data. Then right below it, the period multiplier is hard-coded to 4. So when the code needs to calculate something standard, like a 14-period RSI or a 20-period moving average, it just multiplies that period by 4. So a 14-period RSI becomes 56, and a 20-period SMA becomes 80. It's a really simple, clean way to get that 1-hour smoothness with 15-minute responsiveness.
All right, so we've got our clean data. Now it's time to get into the real core of the system, the proprietary panic/alert score, or PPAS engine. This is where the tool takes each of our top 40 coins and analyzes them across 10 different dimensions to spit out a single final risk score from 0 to 100. This table from the tech spec is basically the secret sauce. You can see the 10 different metrics, everything from technical stuff like rebound probability to fundamentals like on-chain data. But just look at that V3 weight column. It is immediately obvious that the two metrics at the top are doing almost all of the heavy lifting. The system has a very, very strong opinion about what really signals risk.
And this chart just makes it crystal clear. A full 40% of the entire risk score comes from just two inputs: rebound probability, which we're going to dissect in just a second, and the technical analysis score. That TS score basically bundles together classic indicators like RSI, which measures momentum, and ADX, which measures the strength of a trend. So, a high TS score means a coin is in a really strong trend, which is the exact opposite of the choppy, sideways market a gridbot needs to survive.
Now, this weighting isn't random. There's a real philosophy here, and it's all tailored for gridbots. First, they boosted the weight of the technical analysis score, because a strong trend is public enemy number 1 for a grid strategy. Second, they cut the weights for static things like liquidity and social score way down, because they were just creating this constant bass noise in the score that wasn't actually helpful. And most importantly, they made rebound probability, or RP, the single biggest factor. It's designed to be the primary one-way detector that screams bloody murder during a breakout.
And that brings us to the mathematical core of the entire V3 system. This is the logic that directly answers our big question: how do you tell good noise from a bad breakout? It all comes down to something called the exponential penalty rule, and it's applied directly to that super important rebound probability score.
So the old version of the algorithm used a simple linear penalty. The new logic is way, way smarter. It's incredibly forgiving for small moves away from the average price, the kind of moves a gridbot actually profits from. But as the price stretches further and further away, the penalty doesn't just grow, it accelerates. It becomes exponentially more severe. It's designed to ignore the noise but scream at the signal.
This bar chart shows you the power of that curve perfectly. At a 10% deviation from the average, the penalty to the score is about 38 points. Okay, manageable. The system sees this as good volatility. But look what happens when that deviation hits 15%. The penalty almost doubles to 70 points. And at a 20% deviation, it jumps to over 100, which instantly sends the rebound probability score crashing to 0. It creates this mathematical cliff, a tolerance threshold that just absolutely hammers large, dangerous moves. Okay, let's trace this in the V2 code right here. First, dev PCT gets calculated. This is the key. It's taking the current price, subtracting a long-term moving average, and turning that difference into a percentage. That's our deviation. Next, the code figures out the penalty. Now, in this V2 version, it's a simple linear function. It just takes the deviation percentage and multiplies it by 1.5. So a 10% deviation means a 15-point penalty. Finally, that penalty is subtracted from a starting score of 100 to get the final rebound probability. The max and min functions are just there to keep the score between 0 and 100. So while the V3 spec makes this way more aggressive with an exponential penalty, this V2 code shows us the basic idea. Measure deviation, calculate a penalty, and lower the score. Simple, but it works.
So, the algorithm has scanned the market, it's applied its fancy stability model, and it's calculated a final risk score for 40 coins. So what happens next? The final piece of the puzzle is turning all that data into a useful and, importantly, non-annoying notification for the user, and that's handled by what's called a state machine.
The system uses this great feature called Smart Mute. And look, anyone who's ever used an alert system knows the pain of getting the same notification over and over and over again. Smart Mute is designed to solve exactly that. Its only job is to make sure you get a notification when something has genuinely changed, keeping the signal-to-noise ratio really high.
So let's just walk through its little decision tree. The first gate is simple. Is the risk score over 85? If it's not, the process just stops right there. If it is over 85, it then starts asking a bunch of questions to avoid spamming you. Is this a branding alert for this coin today? If yes, send it. Has it been more than 4 hours since the last warning about this coin? If yes, send a reminder. Has this situation actually gotten worse? And if all of those are a no, it does one final check. Has the score jumped by 5 or more points since last time? Only if an alert passes one of these checks does it actually get sent. Otherwise, it stays quiet.
And after passing through all of those filters, this is what you get. This is what pops up on your Telegram. It's a dense, information-packed message that takes all of the complex analysis we've been talking about and boils it down into a single, actionable block of text. So let's quickly break down what this is telling us.
The PPAS of 95 is the headline. That is deep in the kill switch zone, a very clear signal to pause any grid bots on this coin. The dev of 13.2% tells you why the score is so high. That's the deviation that's driving the penalty. The rebound probability is at 71, knocked down from its starting point of 100. And finally, you see those pump and dump targets? Those are basically volatility-based price projections, calculated using the coin's average true range, or ATR, to project potential targets.
So we've been deep in the weeds with the code, the math, the logic, but to really get what Venus Radar is all about, we need to zoom back out and look at the philosophy behind why it was built and shared in the first place, because this is not a product from some big corporation.
And this is the whole origin story, right from the creator. It started as a personal tool built to solve a personal problem. There was no business plan, no monetization strategy. It was just a trader building something for themselves, finding out it worked really well, and then deciding to share it with the community for free. And that promise, it will always be free, is a core part of its identity.
And this number, 40, it just perfectly sums up the project's entire design philosophy. It's not about trying to analyze everything all at once. It's about smart focus. By concentrating on just the 40 most active liquid coins every 10 minutes, the tool stays fast, it stays relevant, and it avoids getting bogged down. It delivers insights on the assets that are actually making waves. And you have to understand, this thing isn't just set in stone. The creator is super clear that this is an ongoing process. I mean, the fact that a V3 spec with a new penalty rule even exists is proof of that. The project really thrives on community feedback and open debate about the strategies and the math, which makes it this collaborative effort to build a better risk guardian for everyone. And so all of this leaves us with a really fascinating question to chew on. In the world of quantitative trading, which is so often dominated by these secretive, proprietary black box algorithms, is a project like this the exception, or is it the start of a new trend? Does being radically transparent, showing your code and explaining your math, build a level of trust and utility that a closed system just can't match? It's a pretty compelling thought for the future of how all of us interact with the tools that shape our decisions in the market.